You can forget about this word recursive for just a second and we'll focus on an arithmetic sequence. This is an example of an arithmetic sequence because it's increasing by the same amount each time. We're going up by plus 20 each term. Okay, so it's arithmetic. It's arithmetic if it's decreasing by 20 each term or if it's decreasing by the same amount from one term to the next. And to write a recursive formula, that means to find any term, we'll call it the nth term, and we use the subscript notation, so we'll put that down below the letter A, that says, hey, if you want to find the nth term, then you need to do something to the previous term. That's what n minus 1 means, the term one step behind. And what we're doing is we're adding 20 to that previous term. Okay, so here's some examples of how that's working. The first term is 40, right? The second term, it's the previous term. It's that 40 plus another 20. So the second term in our sequence is 60, right? So the formula we created is recursive because it relies on a previous term and it calculates the next term. You know, a sub 3, that means, hey, look at a sub 2. N minus 1 makes a sub 2. Look at a sub 2 and add 20 to it. A sub 2 is 60. 60 plus 20 makes 80. So that makes our third term in our sequence just like it's supposed to. Okay, so that's a pretty long explanation. I'll do another one, but that's the recursive formula. You see other notation too. I think that's the most common. We'll just stick with that. Okay. So this is an arithmetic sequence, we're told. That means they're increasing or decreasing by the same amount each time. And so sometimes it's hard to spot. One thing you can do is take the next term, the second term, and subtract it by the first term. So take negative 5/4, I'm going to subtract it by negative 1/2. And whatever that result is, that's how much it's changing by in each term. So I need common denominators, and I can change that to an addition problem. So I'll multiply the top and the bottom by 2. So negative 5/4 plus 2/4 makes negative 3/4. So that's the difference. That's what's happening each time. If you take negative 1/2, and if you subtract 3/4 from it, and I'm using subtraction because it's negative, then you get negative 5/4. Look, let's test it out and see if I've got the correct common difference here. The negative means we're backing up each term. So if I take negative 5/4 and I subtract 3/4 from it, then negative 5/4 subtracted, I can subtract the numerators because I got common denominators. So negative 5 subtracted by 3 makes negative 8. And that works out. That makes the next term that we expected. Okay, so I used a little bit of logic and I found out what's happening each time. It's negative, so that means we're going back 3/4 of a unit each term. So to make my sequence for the nth term, we just use the letter n because that means, hey, whatever letter you're talking about, whatever number in the sequence you're talking about, we can help you calculate it. Just take the previous term and subtract 3/4 from it. Right? Because like we said earlier, you're taking the previous term, you subtract 3/4 from negative 5/4, get negative 2. So that's the recursive sequence.